Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, my students? Today, inshallah, we will complete chapter 11 about motion, section 2 acceleration, pages 372 to 377. Today, inshallah, we will discuss the first part 372 to 374. By the end of this lesson, inshallah, you will be able to describe acceleration and how the object accelerate, calculate the acceleration of an object moving in a straight line, explain how the graph can be used to find acceleration. How can you tell that an object is accelerating? What changes when an object accelerates? Most of us think that acceleration means speeding up, move at high speed. Is it correct? Let's see. Acceleration and motion. When an object undergoes acceleration, its velocity changes. What is the meaning of this? If you remember, velocity means a speed and direction. So, when the object undergo acceleration, the speed changes or the direction change. Recall that the velocity has both speed and direction. Like velocity, acceleration has a value and direction. Acceleration is change in velocity of an object over time. Velocity divided by time. This is acceleration. So, an object accelerates if its speed or direction or both change. So, acceleration is not just speeding up. It can change in speed, speeding up, or slowing down, or a change in direction, even the speed is constant. So, I am accelerating because I'm speeding up, or I am slowing down, or I am changing direction. As we said, acceleration can be a change in speed, an increase or decrease in speed is an acceleration. So, acceleration is increase or decrease in speed, not just increase. This example is in your book. Suppose you start moving south on your bicycle and speed up as you go. Every second you are speeding up by 1 meter per second. This is your speed. And we said velocity because you are moving to south. After 1 second, your velocity is 1 meter per second, then 2 meter per second. After 5 seconds, it is 5 meter per second to south. Means you are accelerating. And acceleration here is increase of 1 meter per second per second. So it can be 1 meter per second square to south. Also, acceleration can be change in direction, change in speed or direction. The rider is accelerating because he's changing his direction. Also, the car here, when the car turns like that, there is acceleration. Why? Because there is a change in direction. Uniform circular motion has a centripetal acceleration. What is the meaning of this? If you are moving at constant speed, means there is no change in speed, but you are moving in a circle. So the speed is not changing, but you are changing direction because you are moving in a circle. So your direction is always changing. When direction change means that you are always accelerating. Like what? Like the moon. Moon is constantly accelerating in its orbit around Earth. Why? Because it is orbiting Earth in a circular motion, so it is changing direction, means it is accelerating. Are you surprised to find out that you are stand still on Earth's surface, but actually you are accelerating? Yes, you are not changing speed, you are standing up still, but you are moving in a circle as the Earth revolves around the Sun. So, if an object is moving in a circular motion, means it is always a change its direction. As a result, the velocity always changing, even the speed doesn't change. So this is acceleration, and this kind of acceleration is called centripetal acceleration. There is example here of this kind of acceleration, like Earth revolving the Sun or other planets revolving the Sun, moving of a car in a circular motion, spinning a ball, or going through a loop on a roller coaster. All of these circular motion causes acceleration. Why? Maybe speed is constant, but you are changing direction, means you are accelerating. How can we calculate acceleration? As we said in the beginning, to find the acceleration of an object moving in a straight line, you need to measure the object's velocity at different time. It is velocity over time. So we calculate the average acceleration, or A average acceleration equal to the average velocity, which means final velocity minus initial velocity divided by time. This is the average. The unit of acceleration is meter per second, or we can say it meter per second square. This is how we calculate acceleration. Inshallah, in part 2, we will apply this on math skills, and we will learn how to graph acceleration and how to calculate acceleration from a graph.